before. That's because I'm a technical person and I can't do any talk about all this other stuff, but I try to make it as easy to understand as possible. So if it gets too technical, just raise your hand and who or do something. So what I will do today, I will try to go a little bit into the IoT world, because that's where we come from with Riot, because as I said earlier, we're making this operating system for these things that make up the Internet of Things. So I will just try to underline how important for us it is that this Internet of Things stays open for the future, and just try to put it in context what the Internet did so far and what we experienced. So one very important thing, I think, is that the Internet, as we know, it basically is based on open, freely accessible standards. If we wouldn't have those standards, the Internet wouldn't work. I mean, the basic idea is, of course, that every computer in the world can basically talk to every other computer around the world, and this is only possible because we have a set of all these different kind of standards that we're using. I think the probably most well-known perfect stack is Ethernet with IPv4 or newly IPv6, TCP, HTTP on top, so there you go, there you have the web. And of course you have all these other protocols. I mean, this list is not exhaustive, it's just to give you basically a rough idea. And these standards, we have some organizations around the world, like the IEEE, the IETF, which is very important, the WCC. And those organizations, actually, they are very open. So anyone in this room could just try to write a draft, send it to these organizations, attend their meetings, and you have a chance in getting your idea into a public standard. So it's very, you don't have to pay any fees, you don't have to be in a certain kind of organization, you just can basically go there and then just start to bring your topics into those organizations. And that's what we, from the Riot point, think that this is actually what we need. We need this openness around it, so everybody can influence it. And yeah, so if you look at all these different kind of networking layers, and you just pick basically a protocol set which you need, then you can just put your own stack together and tell other people what you're using, and other people can just do the same thing, independent of what kind of software they're using, and just connect to your parts, because those protocols are just the kind of the glue that keeps it together. The same is true. Oh, sorry.
For the lay people here, I don't know if there are more than just one.
Yeah.
But can you explain what the green squares are?
Oh yeah, of course. I mean, when you in computer networking, what you do is basically you layer stuff on top of each other. So if one computer wants to talk to the other computer, it's not just basically dial a phone number and there you go, there you have a connection, you can talk to each other. But you have different, basically it's called protocol layers. So one protocol, say the lowest layer, the link layer, it's the physical stuff. If you have an electrical wire and you can switch your level from high to low, the other part, on the other end of the cable, doesn't necessarily know what you mean with, oh, now it's high, or no, it's low, or no, it's been high for 2 milliseconds, no, it's low for 3 milliseconds. I have no idea what it means. So you need a protocol that actually states, hey, when I have my signal low, and then high, and then low again, and do this every millisecond, this means, I don't know, I send you the number 8. So the other part knows, oh, this is the number 8, I know that. So you need a protocol, basically, for the wire. And then imagine the internet, you don't have basically just one line from the person you want to talk to you, but you're connected to a server that is connected to another server, that is connected to a router, that is connected to another router, and so on. So you need to have concepts like how do you route your information through this kind of network? Which route will you take? What's the best way to go, and so on. And there's another kind of protocol set you put on top of it. So on your information package that you actually want to send, you prepend a little bit of extra information, which is just for this routing stuff. And then you prepend another bit of extra information for this wire encoding stuff. And then this is kind of what you call the layering in networking. And this is what you see here. And I think most people in the room know perfectly well what HTTP is or what JSON means. And that is kind of just the very upper part of this protocol stack. And these other ones are the more technical things. I think most people know probably IP addresses. Those are actually the more or less unique addresses which are mostly basically like a host address. So either the internet or the network of computers knows where to put your information to. And it's quite complex stuff, these protocols. But the trick is that if you just look at one protocol at a time, you basically, it's this divide and conquer paradigm which you use everywhere in computer science. So you just can concentrate on one aspect of all this stuff. And so you basically make it more easy. And what you then do when you write an operating system or your network stack, you just implement all of these protocols basically more or less independent of each other, and you can just then connect them together, and then you have a working network stack. And it's been done, I mean, for your normal computers on Linux, on Mac, everything is built in, you don't really have to care about it. And what we do this on the small microcontrollers where you just have a very, very limited amount of memory. I just go on, I will get to it, but is it? And so the other part of the internet, I think the internet wouldn't be what it is without open source software. If you look at all the internet backbones, all the internet servers, a majority of them are run with Linux. You have all the web servers, Apache and so on that are running open source software. We have a lot of routing stuff that is done using open software bases. And what we learned is that when a lot of people just work together on these software solutions and make them open accessible to everyone, that is basically the only way you gain trust into the software basis. And so that is what we think, that of course the Internet of Things should keep on this paradigm and also be based on open source software, because only then you can actually look into the code and look into what your devices are doing, and you have a chance to actually find out and fix them and so on. So basically, when we talk about Internet of Things, what is it? If you have the conventional internet, you have devices like your cell phone, your tablet, your laptop, and so on. Everything is connected, mostly via, say, Wi-Fi, and the Wi-Fi routers and connected to the internet and so on. And these devices, I just put here, it's kind of the amount of memory they typically have, more or less. So you have a Raspberry Pi with like a half a gigabyte of RAM. And these are devices that run Linux or Android or on Mac OS and so on. That's very easy. But now we get to the Internet of Things, and as the name already suggests, now we don't just have the internet in the conventional senses with computers and cell phones and so on, but now we have things that are connected to the internet. And things are typical embedded systems, kind of small microcontrollers that are running, I don't know, your microwave, or are sitting in the car, or just some temperature sensors that are sitting on the wall. But these devices differ significantly, because now we're talking about, when we're talking about memory, we're talking in the area of a few kilobytes. So they typically have, say, 16 kilobytes of RAM and then some say, 50 kilobytes of hard drive, if you call it like this. So you have to see that when you connect these devices to the internet, they have to speak, of course, the same protocols. They have to speak exactly the same language as the computers, otherwise they couldn't talk to each other. But it's, of course, it's a huge challenge to put these network stacks, which we know, on these devices, to trim them, to kind of think about what of the features of these protocols do we actually need, where can we save space, so to fit them on these devices. And so what happens nowadays, this is a typical picture, what kind of right now in the moment, what it's done. Of course you have the internet, and you want these small things on the bottom that are the small devices that you want to connect to the internet. And so what it has done, that these devices basically speak proprietary protocols. So the vendors that sell you these products, like light bulbs or that can change color or all this kind of stuff, they connect to their proprietary gateway. So you have basically a big box you buy from this vendor, you plug into your router or into your Wi-Fi, and then these devices connect on proprietary radio frequencies or radio protocols or on proprietary networking protocols to these gateways. And then these gateways do kind of a transition of the data so it can be sent to the internet. And as a solution might work quite well, it has, of course, some problems we see. For one, you don't know what these devices are actually doing or talking, because you can't look into them. Then there's a problem, say you have a certain vendor solution you just have all around your house. The vendor goes bankrupt, the protocols are just closed and stored somewhere and you can't access them. So 3 years later you see, oh, the encryption they're using, it's not safe anymore because somebody hacked it. Yeah, basically all I can do is throw these devices away because I have no chance of updating them or doing anything with them. And that is exactly what we're about. That we see the Internet of Things. This red color is not really a wise choice, I guess. I tried to read it to you, maybe then it's easier. So, so the vision, and this is kind of a very, I was trying to be a little bold about this vision, so don't take every single word very to the point, but it's just to give you an idea what our community is about and then what our mindset is about. So we would like the IoT, and the first one is to be an open and decentralized ecosystem. So we want to get away from these siloed solutions, but we want to be about having open software running on these devices, at least to some extent. So everybody could, for one, bring their product into this thing, but also on the other hand, you have control over these things you put into your network. You can decide if you want to share it with some random cloud or just with your own device or with your friend or with not. And so the second point is we want to make it accessible to everyone. Of course, it's very technical, and these embedded devices tend to be very industry grade, and it's very like high learning curve to get into them and to program them. But we want to make it kind of easy, and only if it's open and there's kind of standard systems about it, people can think of, okay, how can we can translate this technical part into GUIs or something that normal people can understand and use and know about kind of what it means to think about them. And of course, we want to make them interoperable. That's the last one. That is very important because, as I said, we don't want these devices to be able to speak only with a kind of very fixed amount with devices or with predefined other devices. We want to make it interoperable, which means you can take any device from any vendor running the same software to any computer in the world, basically. So we break this paradigm of silos away and get to real end-to-end connectivity, which means any sensor can speak to any other thing, or at least technical could. Of course, you can constrain it by configuring gateways and so on, and firewalls, and like you do in the internet, basically, also. And so as key enablers to enable this, we see, for one, we need open standards, open freely accessible standards. We need open source software, and of course we need open tools. Because, I mean, software development nowadays, it's all about the tools and everything that helps you to do it. And so the key things here are we want to be this end-to-end connectivity per default. So we want to enable these devices to really take place in the internet, to speak to every other device, which is done, of course, by following those open standards and those open internet protocols, which means not that silos are not possible. Of course, you can configure them technically as a silo for privacy reasons or for whatever you wanted. But you're not forced to do so, and that is the important point. So you can choose to do it. And so that is what we think. I mean, that is the basic idea behind the internet. That is what made the internet what it is today, because everybody was following these standards. And so we see some movement from the industry right now to move away from open standards, to make their own interest groups, and of course you could access their protocols, but you have to pay for them and so on. And that's not it. I mean, that's not where we want to go in the future. And the second important thing is we want the prevention of this device lock, so-called device lockout, which means you buy a device by a vendor and they don't give you anything about the software, whatever it's running on them. And so what I said, you just have this device and you can throw it away if you can't use it anymore. But you have no chance to get into it, to know what's running in there, to update something. And we want to open that up. And so there's basically, it's also the main point of that this post-Snowden area where you want to have privacy and then you want to control the privacy actually. And that's again where we connect to this whole concept of decentralization. Only if you're able to tinker with your devices and update your software and so on and control who they connect to, when do they connect to, what data they send, who do they share this data with. Only then this Internet of Things, I think, is actually something you will trust in the future. And so a little bit about like how we fit in with the project. Like I was saying, which you can't read now, is if you can't run Linux in your device, then run Riot. So basically, it's a very long shot, and it's very kind of a little bit over the edge. But we basically want to become the Linux for the embedded world, for the small embedded devices that you connect to the internet. And of course, we are far away from that. But we see Riot as a platform for these open standards. So we really try. I mean, we are a pure open source project, and we now had a long discussion about these open source licenses, and we now decided that we will definitely stay with LGPL as our license, which means you can't just not take Riot, change a few parts, make it kind of closed source, don't open up your changes again and run with it, but you have to share your changes back to the community, which we probably lose a lot of industry interest, but anyway, we try. And so also you envision Riot to be kind of a platform, same as Linux with the Linux distributions. So when you want to use Linux, you probably use Debian or Ubuntu, or like somebody put something on top of it and then build kind of a usable system around it. And that's what we see for Riot as well. We basically provide the platform with these open protocols and so on, and then it's up to you what you put on top of it. So we would imagine other projects basically basing their ideas onto Riot. And yeah, so that's how we hope that we can kind of push this whole idea about these open standards and so on kind of to a more usable level. We kind of try to make it easy to develop with these small constrained devices, take those hurdles away, and give you a base platform that already works on all these microcontrollers, so you can actually focus on connecting these devices and on turning out your ideas and I don't know, connecting it to your own Freedom Box, for example. So, that's it.
Thank you. So I think it's a super interesting talk, and I think this IoT